Hi there. So in this video, we're going to talk about our third method of solving systems. Last time we talked about solving by graphing, and we said that's not a great method because of a few different reasons, and that led us into substitution. And we talked about that, and now we have elimination. And like I said in class the other day, most of the time you guys are going to be able to pick what method that you want to use. And I will say that oftentimes problems are going to be set up in a way that are conducive to substitution versus elimination, and you kind of have to decide, the best route in those problems. I look at this problem right here, and last time we talked about how we pick the easiest letter to get by itself. But if I look at these, every single one of these letters has coefficients in front of them. And we could get any one of these four letters by itself or isolate them, but then we would have some messy fractions involved. And so a better option is this process of elimination. Now, our goal in elimination is to eventually be able to add our two equations together to get one of the variables to eliminate. But as it stands, if I add these two equations now, well, this would become 7x, and this would become negative 1y. I haven't been able to eliminate either one. So I have to do something first. And what we need to do is decide, do I want to eliminate the x's or the y's? This problem is not going to matter which one you pick. Sometimes it might be easier to eliminate the x's or the y's. You'll just have to kind of look at that. But here, my goal is this. Either in front of the x's or the y's, I want to get the same number with opposite signs. Okay? Now, I teach it this way. You technically can just get the same number and subtract the equations. That is allowed. But I find a lot of students make mistakes with that, so I don't really show that very often. But if you're comfortable with subtracting and signs and things like that, feel free. But on this problem, you could either turn these x's into 10s or the coefficients of the y's to be 12s. It's completely up to you. But I would encourage you to get one positive, one negative. So let's just focus on the x's. If I want to make this a positive 10, I'm going to multiply the whole top equation by positive 2 and create a new equation. So my new equation would be 10x plus 6y equals 18. Now, if I have a positive 10 in front of the top x, I want a negative 10 in front of the bottom x. I want to turn this 2 into a negative 10. So I'm going to multiply the bottom equation by negative 5. So I'm going to get negative 10x positive 20y equals negative 50 and 20, negative 70. So I multiplied the whole top equation by 2 and everything in the bottom by negative 5. Now I'm going to add these equations together, and what should happen is one of the letters should go away. So these x's are going to cancel. This becomes 26y. And then this is going to become negative 52. And now I have an equation with just y, so divide, y equals negative 2. I still need to find x, so now you have options. You could plug negative 2 back into any of these four equations up here. The two you started with, the two new ones, completely up to you. I'll just pick this very first one because everything's positive. So I'm going to plug negative 2 in for y. So I would have 5x plus 3 times negative 2 equals 9. That's negative 6, so add 6 over. 5x equals 15. X is 3. And you could check these just like we talked about the other day very easily. Plug them back in for x and y and see if both equations work out. Now sometimes, I have this system here, example 2. Sometimes the terms aren't lined up as they need to be. So if I look here, notice how I have x and y on the left side, and then over here I have y on the left and x on the right. So before I do anything with elimination, I want to line all the terms up. All I really need to do is subtract this 2x over to the left to make that happen. So I'm going to move this 2x over, and I'm just going to rewrite the bottom equation as negative 2x positive 4y equals 1. And a lot of times when I change an equation, I didn't talk about this up here, but a lot of times when I change an equation or multiply, I'll kind of lightly cross it out. I say lightly because I might still want to use it later to find the other letter, but that way I don't get confused later on throughout the work. And I think that becomes more important when we get into 3 equations, because it's very easy to lose track of what you're working with. I see more mistakes made with students just accidentally add two wrong numbers together because they just got sidetracked throughout the problem. So I just crossed this out. So now I'm dealing with this top equation and the bottom equation. And again, the goal, I want to get the same number in front of the x's or the y's with opposite signs. So if this is a -2 here, then I'm going to multiply the top equation by +2. And that's going to become +2x, -4y equals 6. And now I'm going to add these together. So this one, the x's go away and the y's go away. I'm still left with a number. I get 0 equals 7. And now think about what that meant back in first semester when we solved these, just regular equations. When you get an untrue statement, your answer is no solution. That means there's no solution to this system. All right. If we had done this and we got like 7, this is something good to talk about. If we got like 7 equals 7, then that would mean infinitely many solutions, which maybe I have one of those on the notes. I'm not sure yet, but just in case I don't, that would mean that there's infinitely many solutions. Example 3. Well, in the other ones, I got x's to be the same, so this one I'll get the y's to be the same. So if that's a -2 here, I want this to be a +2. So I'm going to multiply it by -2. Oh, that happens on this one. So I get -4x, +2y equals -2. And now I want to add these bottom equations together. I get 0 equals 0, which means that this system would have infinitely many solutions. Example 4 looks a little tougher because I have these fractions to deal with, but kind of like in example 2, I just want to line everything up. And this goes back to what we learned when we solved fraction equations. I would highly encourage you to get very comfortable with eliminating fractions. And so I'm going to multiply everything in this equation by, in this case, 12. That's going to cancel out both denominators. I'm not going to get common denominators and combine these fractions. That is an option you could do, but I'm not. I'm going to multiply everything by 12. So times 12, times 12, times 12, even the 1 on the other side. What happens is, think back to first semester, we take the 12 and the 4 and we reduce. So I'm going to reduce those to 3. And now I multiply 3 to x plus 3, that quantity. It's kind of like it's in parentheses, so I'm going to distribute it. So that's going to become 3x plus 9. The 12 and the 3 reduces to 4 and distribute, so 4y minus 4. And then equals 12. And then I want to line all this stuff up, so 9 minus 4 is 5. I'm going to subtract 5 over and get 7. So I'm going to have 3x plus 4y equals 7. So just some manipulation before we get to the actual system. So in example 1, I mentioned how sometimes it's easier to get the same number in front of one of the letters, and this is a case where that happens. I could turn the x's to be 6's, but I would have to multiply both equations. But if I look at the y's, if that's a +4, I would just multiply this top equation by 4, and I met my goal. And so you just kind of cut one extra step out if you look ahead at what's the easiest route. So I'm going to multiply the top equation by 4 and get 8x. That's going to be -4y equals 48. My goal is met. Now I can add them together. 11x equals 55. Divide by 11, x equals 5. Now I need to plug it back in, and you have 5 different equations you could plug this into. This one over here, the original fraction equation, no idea why you'd choose that, but you could. And any of these 3 down here. I'm going to pick this one, 2x minus y equals 12, just because they're the smallest numbers. So plug 5 in for x right there. So 2 times 5 minus y equals 12. 10 minus y equals 12. Subtract the 10, so -y equals 2. So y equals -2. 5, -2. All right. The very last one, a word problem. And when we do these, I'll let you choose how you guys want to solve them. And, it's completely up to you. Now that you've learned your methods, kind of identify what's going to be easiest for you. For instance, if I gave you a system like this, and I said solve it any way you want, this is one where it's very conducive to substitution. It's already set up for you. You have y isolated, just plug that in for y. It's set up. This one right here, example 1, it might be tough to get any one of these letters by itself to not deal with fractions, so elimination would be your choice. And it's going to be up to you most times. So the very last problem, an airplane flying into a headwind travels the 1,800-mile flying distance between Pittsburgh and Phoenix in 3 hours and 36 minutes. On the return flight, the distance is 3 hours, because now it's going with the wind, so it'd go quicker. Find the airspeed of the plane and the speed of the wind, assuming both remain constant. So I want to know how fast is the plane going, and then the wind is, when it's going there, it's pushing against it, and when it's coming back, it's helping the plane along, making it go faster. And so I want to find both, the speed of the plane and the speed of the wind. And I'm going to go ahead and define my variables. So I'm going to have x be the plane speed, and y be the wind speed. Now think back to first semester when we did these. Anytime we're dealing with rate, time, and distance, I highly recommended setting up a little chart, and I'm going to do that here as well. I have rate, I have time, I have distance. It says flying into a headwind. That means going against the wind. The wind is slowing you down. So in the first scenario, we're going against the wind. And then on the return flight, we're going with the wind. And try to identify the easiest boxes to fill in. It tells you the time boxes. When you're going against, it takes 3 hours and 36 minutes. But when we're talking about miles per hour, think back, last semester when it said 30 minutes, we would put 0.5. We have to convert to hours. So if it's 3 hours and 36 minutes, we're not going to do 3.36. We need to figure out what decimal would 36 minutes of an hour be. And if you do 36 divided by 60, you'll get that answer. So 36 divided by 60, 36 minutes is 0.6 of an hour. So the time would be 3.6. And then going with, it takes 3 hours. Now the rates are a little tricky at first, but these are all done very similarly. And so if we're going against the wind, think about what happens. Think about the relationship between these two things. You take how fast the plane is going, but the wind is slowing you down. So you take your speed, your plane speed, and subtract the wind that's pushing against you. So it'd be x minus y. But when you're going with the wind, you have your plane speed, and then the wind is helping you. So x plus y. So those are your rates right there. Very common in these problems for that to occur. Now your distance, regardless of if you're going there or coming back, the distance is 1,800 miles either way. So there's our box. Now think about how we set up our equations. Rate times time equals distance. So 3.6 times x minus y equals 1,800. And then from the bottom row, 3 times x plus y equals 1,800. And there's our system, and now we just need to solve it. You have some options here. You're going to be very tempted to distribute these numbers inside the parentheses. That's always habit. I would avoid that. It's not wrong. You can get to the right answer that way. Just more work. I would encourage you right here just to divide both sides by 3.6 of the top equation. And here, divide both sides by 3. You'll see why. But on that top equation, I'm not going to distribute. I'm going to divide both sides by 3.6. And when I do that, I get 500. So I get x minus y equals 500. The bottom equation, I'm going to divide both sides by 3. So x plus y equals 600. Now notice how easy this is to use elimination. The y's are going to cancel right away. I'll say that one of the biggest mistakes students make here when they add these, they forget that 1x plus 1x is 2x, which sounds kind of silly, but I find that mistake made more than most mistakes in these problems. So when I add these, x plus x is not x, it's 2x. The y's cancel, 1100, divide by 2, so x equals 550. So that's how fast the plane's going, which we'll write out here in a second. And then it's easy to find the y value too, because look at this equation. I try to find the easiest equation to get my other letter. Look at this. X plus y equals 600. So if x is 550, y has to be 50. And then I'm just going to write out, a little brief statement about what that means. So the plane speed is 550 miles per hour. And the wind speed is 50 miles per hour. All right, your assignment is going to be all application. You've done these systems through elimination in Algebra 1. This was hopefully just kind of a good refresher. And so the problems you'll be doing for your assignment are going to be all application. So you'll love me for that. But best of luck. Let me know if you have any questions.